a double triangle proof, or it's sometimes called a Detour proof or double congruence proof. Basically what happens is you look at, there's a lot of triangles in this picture. So for instance, there's these big red triangles that seem to be congruent. There's also these blue triangles that seem to be congruent. And there's also these green triangles. So there's a lot of triangles in this picture. Since the goal is to prove that GE is congruent to GF, which is this side and that side, that's the goal. So it seems like we either want to prove the blue triangles congruent or the green triangles congruent. That seems to be the plan. Let's say I'm going to try to prove the blue triangles congruent. What would that look like? Well, one way to visualize this, a proof, is through what's called a flow diagram. So to prove, I'm trying to prove the blue triangle is congruent, because if I can, then I can say that GE is congruent to GF. By CPCTC. So that's my plan. Prove the blue triangle is congruent. And let's just see, maybe this will be easy. Let's see. So AG is congruent to GC. Well, that's good. In other words, I am 1/3 of the way to my proof. Also, I hope you don't mind, I'm going to write numbers here. Angle 1 and 2 are vertical angles. So now I'm 2/3 of the way towards the goal of EGC and FGA triangle. I'm getting really close. I'm just one step away. I already have a side and an angle. Now, if I have an angle and a side, I'm one step away from ASA, and I'm one step away from SAS. Now, there's no way this is going to be an SAS proof, because the piece I would need would be this one, this EG and FG, and I don't know those. Those are actually the things that I'm being asked to prove anyway. So all our attention now focuses on this angle here. I'm going to call these two angles 3 and 4. I'm hoping I could prove angle 3 congruent to angle 4. If I can, this whole thing will work out. But there's actually not enough information, at least right away, to prove that angle 3 is congruent to 4. So let's see what the plan is now. So angle 3 and angle 4 are parts of the blue triangles, but they are also part of, and I'll make this, angle 3 and 4 are also parts of these red triangles. And that's the key. If I just kind of ignore that green, blue, that line in the middle, I have these two large triangles. So what we're going to do, it's called a detour proof, because in order to get that last piece, I'm going to detour. Oops. And prove another pair of triangles sort of first. So I can't finish this job until I prove, in this case, that the red triangles are congruent. Well, good news for you. In these triangles, the given information is that GC equals GA, and it's also given that these sides are congruent. And I can see from the picture that these two large angles are congruent. So I'm going to write this up. DG is congruent to GB, that's given, and also AG is congruent to CG, that's given also. And then I can say DGC and BGA angle those are vertical. These two are given. Now when I put that together, I have enough information to say that the large red triangles are congruent. So triangle DGC is congruent to triangle BG. Oops. I need to be a little more organized here. That's going to be the CPCTC. That's going to be the triangle. Okay, sorry about that. So in this box here, I can say that the two triangles, DCG, that's triangle DCG, is congruent to triangle BAG. Okay, that's by SAS. Now that I know those triangles are congruent, I can say that the other pieces of that triangle are congruent, including, very importantly, angle 3 and angle 4. So I'm going to put that right here. Well, that's just what I needed, because now that angle 3 and 4 were part of both the blue triangles and the red triangle. So once I prove the red triangle is congruent, I can say that angle 3 is congruent to 4 by CPCTC, which gets me the blue triangles by ASA and GEGF by CPCTC. That's the way that works. And once we have it written out as a flow, we can take all the statements and put them into a two-column proof, which looks something like this. So these givens together with the vertical, that's what I needed for the first pair of congruent triangles. The CPCTC on angles 3 and 4, that was a piece I needed together with the vertical and actually the given. That AC and CG is part of both triangles. That's why we see it actually twice here and here. It only needs to be written once in the two-column proof. So that's how these detour proofs go. Sometimes you have to prove the small triangles first and then use them to prove the big triangles. Or in this case, we found the big triangles first. So it's hard because there could be many triangles and it's hard to know which pair. The trick is, which pair am I close to? Even if it's not the pair we ultimately want, prove any triangles congruent that you can, and it's probably going to lead you towards the answer, because you can't prove the little triangles without first proving the big triangles in this case.